So we have an arithmetic sequence, and we can see that it's going 10, 12, 14, 16, 18, and these would be considered the place that the number is in. So the biggest thing that's confusing for students is we have numbers talking about numbers. So in the first place, we have 10. In the second place, we have 12. Third place, we have 14, 16, 15, and so on. And we're going to talk about this nth number. Now, the nth number is simply the number that we might be trying to find. It's some way, way down the road. So, if I wanted to find the 99th number, I would then use 99 in our formula where we see n. Okay? So, we have what's called the common difference, and we use the letter D for that, and that's simply the difference between consecutive terms, and in this case, the common difference would be 2. So in this example, the D value would be equal to 2. We have an explicit formula, which we'll talk about first, and I'll show you another one at the end. But the explicit formula shows the nth term, so the number that's way down the line of a sequence in terms of that particular place. So we would say that AN, now this letter A can change. Don't be confused by that. It could be B, C, D, whatever it wants to be. But it also uses the first term in the sequence. That's why they're numbered 1, 2, 3, 4. So we use this first one. In a sequence, the first term is 7. Let's label that A1. Or do you want to use a different letter for something fun? Want to use something different? Don't matter? All right. Common difference, positive 8. Nth term is 18. Okay? To stay consistent, there's nothing wrong with going like 1, 2, 3, 4, kind of like building your own here. Obviously, you wouldn't want to keep doing it all the way out to 18. That kind of take you a while. They said the first number was 7. Then we're adding 8. So just add 8 every time. 15, 23, 31. But I don't want to keep doing that. That's just going to be too long. Yes? If you did do that, so we're going to just use that formula, right? So we've got AN equaling the first number plus, now I'm going to change it up here a little bit. I'm going to put the common difference first and then n minus 1. Because of the commutative property, this could be on the back side, it could be on the front side. It's not going to change. So we're going to do parentheses first. The person that wrote this packet put it second. I have it first, and I want you to get prepared for that when you see it on the practice that way, because the practice assignment is in fact mine. Let's go ahead and plug in some values. We got the 18th term that we're looking for. We know that the first number was 7. We are increasing by 8, and we're going to do that 1 less than the number we're trying to find. Okay? So if we're on the first step, if we know the first number, we can do it 1 less than what we're trying to find. So 18 is equal to 7 plus 8 times 17. And maybe seeing that number in front of the 17 rather than behind it makes it a little bit easier for you. So this is going to be 7 plus 17 times 8, 136. Add your 7. The 18th number is 143. Okay? So again, we're brought a question. Instead of seeing them written out in like a pattern, they tell us the things we need to know. They always have to tell us the first term. So let's keep it A. So A1, that is subscript. That's a number below the level of the other letter. So A subscript 1 is 12. Increasing by 3, the common difference is positive 3. Yes, the common difference can be a negative, and look at that. We've got to find the 200th term, okay? Let me talk to you a little bit about the recursive formula and how this one works. So the recursive formula takes the number you're looking for, okay, and uses the 1 before it and simply adds the common difference. So if we were trying to build this set of numbers, all right, if we were looking for, that's not a good place to put this. If we were looking for the first number, the second number, the third number, the fourth number, we'd already have the first. And what do we know? We know that we use the first number to find the second number, right? So what's the second number? We already know this. 15, right? We're just going to add 3 to the previous number. What are we going to do to find the third number? We're going to add 3 to the 15, which is the second number. There's 18. And what are we going to do to find the fourth number? Add 3 to the 18, which is the third number. So we have this process of just going back one place and adding 3 to it. And so that's what this says right here. Okay, if we want to find the second number, because we already know the first, what we're going to do is 2 minus 1 and add 3. What's this 2 minus 1? 2 minus 1 is simply 2 minus 1 making it the first number. And we're going to add 3 to that. What's the number in the first spot? 12. 12 plus 3 is equal to 15. So the recursive rule does exactly what your mind would think to do. Add 3 to the previous number and keep going up by that. Let's do it one more time just to kind of show you what I would want to do to find the third. Okay? Clearly, I would use this, but we already know. What's 3 minus 1? 1 second. What's 3 minus 1? 2. We're going to need to know the second number. What are we going to do to that second number? Add the common difference. Add 3. What is the second number? 15, right? We're going to add 3. That's going to make 18. So that is your recursive rule. A lot of times students get hung up on this part right here, but it's just showing you how you go backwards 1 to move forward by the common difference. Next term. So would this be a great process to use to get all the way to the 200th term? We're going to be here a long time, right? We're going to be a long time because every time I'm going to add 3 to the number before it. So that's not going to help us out that much. Let me get rid of this. This is not necessary. And let's go back to the explicit. This is going to zoom us right to the number we're looking for. So AN is equal to, we take the first number, we add, I'm going to put the D first, the common difference, and we do that 1 less than the number we're trying to find. So from the question, we're trying to find the 200th number. The first number, 12. How much are we increasing by? 3. And how many times do we need to do that? 200, but 1 less, 199. So we'll write it as 200 minus 1. If you want to start shortcutting this and just writing 199, I think that would be totally fine. So 12 plus 3, 199 times. I'm just going to go right to the calculator. I've already done this. The number that you would be looking for is 609. Okay, so there you have it.